In this video, we will discuss one of the most important topics in statistics, measures of variation, range, standard deviation, and variance. To visualize the variation of data, let's take a look at two data sets that represent the numbers of chocolate chips in the chips Ahoy regular and reduced fat cookies. Both samples consist of 40 values, or 40 cookies. Dot plot is one of the graphs that helps us to compare different data sets. As we can see from these two dot plots, Ahoy regular ranges from 19 chocolate chips per cookie to 30. We can point at the minimum value in a dot plot and the maximum value. Or we can look at summary statistics. Minimum value, maximum value, and Ahoy reduced fat type ranges from 12 to 28 chocolate chips per cookie. Range is the difference between the maximum value and the minimum data value. In Ahoy regular, range is equal to 11, maximum value 30 minus minimum value 19. In Ahoy reduced fat type of cookie, range is wider, is equal to 16, 28 minus 12. Range tells us how much data varies overall. Range may increase significantly with the outliers, so it is not a resistant characteristic. Standard deviation measures how much data values deviate from the mean. Standard deviation in Ahoy regular sample is equal to 2.6 approximately, and in Ahoy reduced fat is equal to 3.8. To better understand and interpret this important characteristic of a data set, let's take a closer look at definition and description of standard deviation. The standard deviation of a set of values is a measure of how much data values deviate from the mean. Simple standard deviation is abbreviated as S. Population standard deviation is abbreviated as small sigma. The important properties of standard deviation is that the value of a standard deviation is never negative. It's zero only when all the data values are exactly the same. Larger values of standard deviation indicate that the data value is farther from the mean. The standard deviation increased dramatically with the outliers. The units of standard deviations are the same as units of the original data values. The sample standard deviation S is a bias estimator of the population standard deviation sigma. The formulas to calculate standard deviation of a sample and population are presented below. We will take a look at how to manually calculate the value of a standard deviation of a sample, but good for us, there's technology to help us do the complicated calculations. I'm going to copy the first 5 values from a data set of Ahoy reduced fat cookies. Using the formula for sample standard deviation, square root of the sum of the square difference between each value and the mean of the sample divided by the number of the values minus 1. Let's make a table to help us do these calculations. To break this formula into parts, we first need to know the mean of this sample. Let's go back to the StatCrunch. I copy our small sample from 5 values in a separate column, var4. To find the mean in StatCrunch, go to Stat, Summary Stats, column. I'm going to choose the column where I have my sample, var4, and calculate mean. The mean of this data set is 18.4. Now I'll do manual calculations. Each value subtract the mean and then square it. And at the end, I'm going to find the total and use it in the formula. 13 minus 18.4 is equal to negative 5.4. 24 minus 18.4 is equal to 5.6, and so on. Let's continue calculations with the rest of the data values. Once we finish with finding the difference between each data value and the mean, we will square each difference and write the result in the next column. Negative 5.4 squared is equal to 29.16. 5.6 squared is equal to 31.36. Let's continue squaring the rest of the differences. Once we finish with this part, add all the values, which is equal to 73.2 What we just found is this part, 73.2. Let's plug it into a formula to find standard deviation, which is equal to square root of the sum of the squared differences, 73.2, divided by n minus 1. 4 is equal to square root of 73.2 divided by 4. I'm going to use the calculator to find the square root of 18.3, which is equal to 4.2778. The round-off rule for measures of variation is to round to one more decimal than the original data value. The original data values were presented as whole numbers, so we round standard deviation to one more decimal, 4.3, and remember we use the same units of measurement as the original data values. Since we measure the number of chocolate chips in each cookie, 4.3 is the number of chocolate chips in the cookie. I wanted you to know how to do manual calculations for standard deviation so you have better understanding of why the standard deviation is never negative, because it has the square values. We will now find the standard deviation using StatCrunch. Go to Stat, Summary Stats, Column, choose the column with our data, var4, choose characteristic you want to find, mean, variance, and standard deviation. Let's also choose the range as one of the characteristics of the variation. Compute. The mean of this data set, as we found before, is 18.4. Variance is square of the standard deviation. Standard deviation is 4.27, approximately 4.3, squared 18.3. Variance is another characteristic of a variation of a data set that is equal to square of the standard deviation. Sample variance is S squared and population variance is sigma squared. Here's the notation summary. S is a sample standard deviation, S squared sample variance, sigma population standard deviation, sigma squared population variance. The important properties of variance. The units of variance are squares of the units of the original data values. The value of the variance can increase significantly with the outliers, so variance is not resistant to the outliers. The value of the variance is never negative because it is squared. It can be 0 when all the data values are the same number. Basically, there is no variation in the dataset. The sample variance S squared is an unbiased estimator of the population variance, sigma squared. Let's take a look at 3 concepts that can help us understand and interpret the value of standard deviation: the empirical rule, the range rule of thumb, and the Chebyshev theorem. According to the empirical rule, 68% of all data values lie within one standard deviation from the mean. 95% of the values in the dataset lie within 2 standard deviations from the mean, and 99.7% of all the data values are within 3 standard deviations of the mean. The range rule of thumb is another way to understand the standard deviation. It's a very approximate but simple tool for interpreting the standard deviation. Since the vast majority, 95% of sample values, lie within 2 standard deviations of the mean, we can use this rule to find significant low values and significant high values. The values that are not significant are located between 2 standard deviations from the mean. Significant low values located the mean minus 2 standard deviations. Significant high values located mean plus 2 standard deviations. If the standard deviation is not known, we can approximate it by dividing range, which is the difference between the maximum data value and the minimum data value, by 4. The proportion of any set of data lying within k standard deviations of the mean is always at least 1 minus 1 over k squared, where k is any positive number greater than 1, according to Chebyshev's theorem. For k equals 2 and k equals 3, we get the following statement. At least 3/4 or 75% of all values lie within 2 standard deviations of the mean, and at least 89% of all the data values lie within 3 standard deviations of the mean. Let's look at how we can use the empirical rule on the following example. By the way, I forgot to mention that empirical rule applies to data that has approximately normal distribution or a bell-shaped distribution. The IQ scores have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. What percentage of IQ scores are between 70 and 130? Let's draw the bell-shaped distribution of our dataset with the mean of 100 and a standard deviation 15. Remember, according to empirical rule, 95% of the data lie within 2 standard deviations, 68% of the data lie within 1 standard deviation, and 99.7% of all the data are within 3 standard deviations. So in order to answer the question, what percentage of IQ scores are between 70 and 130, we need to find where are those values, 130 and 70. 100 plus 15 is equal to 115, plus 15 will be 130. This is 2 standard deviations. The value of 130 is 2 standard deviations from the mean. Subtracted 15 from the mean will give us 85 minus another 15. Remember, standard deviation is 15. 85 minus 15 is 70. 70 is the value that is located 2 standard deviations from the mean to the left. So the percentage of the values that are between 70 and 130 is 95%. Coefficient of variation is used to compare variation in different samples or populations. Coefficient of variation is expressed as a percent and describes the standard deviation relative to the mean as is given by the following formulas. Sample coefficient of variation is the standard deviation of a sample divided by the mean of the sample times 100. Coefficient of variation for the population is population standard deviation divided by the mean times 100. Coming up in the next video, Chapter 3.3, Measures of Relative Standing, Z-score, and percentiles, and building and interpreting the box plots. I'll see you soon.